Good morning.
Good morning, ma'am.
Good morning, ma'am.
Is my screen visible?
Yes, ma'am.
Okay.
Yes, ma'am.
So we will continue to discuss the different accessories used in case of the boiler. So accessories means these are the integral part of the boiler to increase the boiler efficiency. So last class we had discussed about the feed pump. Then we have to discuss the injector. So feed pump means that will utilize to supply the feed water to the boiler. So there are the two different types of feed pump. One is the rotary type, another one is the reciprocating type. So reciprocating type of boilers, feed pumps are used in medium-sized boiler. Okay, rotary feed pump or centrifugal feed pumps are used small steam turbine that can be driven by the steam turbine or electric motor. So in centrifugal type of feed pump, we are having the casing as well as the impeller. Okay, so that pumping of the liquid will be achieved with the help of the centrifugal force of the uh, force of the rotating impeller. Okay. So today we are going to discuss about the fuel injector. Sorry, that is the water injector, not exactly the fuel injector. In some places, we are using the injector. Okay, in some places we are utilizing an injector because it is more efficient than your feed pump. Okay, because in this case, the some amount of steam will be utilized in pumping of the liquid water. So in that case, what will happen? The water which is supplied to the boiler already it is preheated with the help of that injector. So injector, if you are observing in this case, it is the sketch of the injector. So here it is the steam cone, and P is your spindle, H is the handle, and T is the pointer. So when we are rotating this handle, so this T pointer will shows the position of the valve. That means whether it is open or closed. So during the movement of the handle, this spindle will move, and through the point A, the steam will be supplied through this steam cone, and another side there will be the supply of the water. So both steam and water will be supplied to this combining cone. So where that steam, that water will utilize to condense the steam. So both will enter to the delivery pipe after passing through this combining cone. So here what will happen? The water will gain some temperature. So because of that, the heat supplied to the water will to the water to generate the steam will be reduced. So that condensate or the water with the high temperature will enter to the delivery cone. This is the delivery cone means it is the side of the boiler. So in this case, another thing is that that kinetic energy of the steam will be increased to the pressure energy. So the inlet pressure of the condensate will be more as compared to the inlet of the steam. Okay, so that steam pressure should be the final pressure of the delivery of these condensates would be greater than the steam pressure to supply the condensate to the boiler. Okay. So otherwise, what will happen? The water will not enter to this boiler. So it should be more pressure as compared to the steam pressure. Okay. So here the injectors are of the different types. So it may be actually this function of the injector is that it will inject the water with the more temperature as compared to the inlet temperature with certain pressure, which is the more pressure than the steam inlet pressure. So this injector can be utilized in case of the vertical and locomotive boilers. Okay. So the one of the advantage of the injector is that it will require the less space as compared to your feed pump. So feed pump, as we have already discussed, they are in case of the reciprocating feed pump. So it will take the more space as compared to this injector. Okay. So in this case, in case of the injector, the kinetic energy of the steam will be converted to the pressure energy. So in this case, what will happen? Velocity of the water inlet will increase. Okay. So the advantage of this injector is it is having the low initial cost as compared to the reciprocating pump or feed pump. So design is just simple as compared to the double acting feed pump. So here it is the here we do not have any dynamic parts. So in this case, thermal efficiency will increase about 99%. So as compared to your feed pump. So another one is the um, ease of operation. So there are the certain disadvantages also. So in this case, if it is required for the large quantity of water to supply to the boiler, so in that case, the pumping efficiency will be less. So large quantity of feed water is required in case of the marine application and large installation or high pressure. In some case, high pressure boilers are required or working pressure is more in that case. So in that case, you may require the large quantity of water. So in that case, your pumping efficiency will be reduced. So if it is the very hot water is there, so in that case your pumping of the hot water is quite difficult, and it because it cannot force very large hot water to the boiler. So in some cases, we are having the irregularity in the operation due to the variation of the this steam inlet pressure. So these are the disadvantages of the injector. Okay, so these are the advantages of the injector. So next one is your this is your diagram for the economizer. So as you all know, economizer will increase the uh, temperature of the feed water by utilizing the waste heat. So it will utilize the waste heat, feed water. Okay, so these are the two types of economizers are available. First one is your independent type. Second one is the integral type. Okay. So this is the diagram for the independent type of vertical tube economizer, also known as the Green's economizer. Okay, it is also known as the Green's economizer or independent type of vertical tube economizer. So independent type economizer means in this case, uh, this type of economizer are placed outside the boiler setting, or we can say that in that this will be installed uh, in chamber apart from the boiler setting. So the boiler, in this case, this economizer will placed uh, in the near the path of the flow. Um, Passage of the flow of the gases. Okay, so first the flue gases which is coming out from the boiler will pass to the economizer, then it will go to the air preheater, then it will go to the chimney. So it is independent time means it will be installed apart from the boiler setting, and the flue gases which will come out from the boiler will be utilized in the economizer first. And then it is the integral type. Integral type means this will be the part of the boiler setting. So this will be situated near to the surface of the boiler, or it is installed within the boiler setting. Okay, so it is independent type, it is the integral type. So this is the schematic diagram for the Green's economizer, which is the vertical uh, tube type, and it is the independent type. It will be placed near the passage of the flow of the flow gases from the boiler. So this economizer is utilized for the uh, medium pressure boiler, where the working pressure will be up to 25 bar. Okay, so here it is the Green's economizer. So if you are observing, we are having these are the vertical tubes, and S is the scraper, and below we are having the horizontal tube, and upper there is the horizontal tube. So this is the bottom tube and it is the top tube. So top pipe or bottom pipe. So through the bottom pipe, water will be supplied. So this is the flow of the water. And here what will happen, it will be the supply of the flue gases. So the water with the low density, after gaining the temperature, it will flow towards the top pipe, that is the B. So here that water with the high temperature will be collected at this point. So this is the delivery side of the feed water to the boiler. Okay. So here we are using the scrappers. So scrappers means, so if the continuous flow of the flue gases will be there, so what will happen at the surface of the tube, vertical tube, that is the P. So what will happen? There will be the deposit of this soot on the surface of the tube. So because of that one, the heat transfer will decrease, and efficiency of the economizer will also reduce. So scrapper will uh, remove that deposition continuously, so that there will be the proper heat transfer from the flue gases to the water. So here in this case, P is nothing but it is the vertical CI pipe. Okay. So scrappers are used to remove the soot deposits to clean the vertical pipe, so that there will be a better heat transfer. Okay. So there are the certain advantages of the economizer. So first one is the because there is the temperature of the water, feed water is increasing. So in this case, what will happen? Evaporative evaporative capacity of the boiler will increase. Hence, your overall efficiency will increase due to this evaporative capacity. Okay. So another thing is that we are minimizing heat loss through the chimney, right? So then fourth advantage is that in this case, um, because the hot water we are feeding to the boiler, so what will happen? If we are supply the cold water to the boiler, so it may uh, provide a chilling effect to the boiler meter, so that there will be the reduction in the temperature of the boiler cell. In turn, it will reduce the evaporative capacity of the boiler. So the cold water may result in chilling of the boiler meter. So it provides the hot water to reduce the chilling effect. So another advantage is that there will be the uniform distribution of your temperature in the boiler surface, on the boiler surface, so that there will be the reduction of the stresses due to the unequal expansion. Reduction of stresses due to um, unequal expansion. Okay, so these are the advantages of the economizer. Next one is the air preheater. So this is the diagram for the air preheater. The function of the air preheater is to increase the temperature of the inlet air to the furnace so that the combustion efficiency of the furnace will increase. So if the air is having the moisture, so in that case what will happen? There will be the more heat will be required or more fuel combustion will be required mm, or more feeding of the fuel is required to get the sufficient combustion. So it is generally placed after the uh, after the economizer. Okay, so first the flue gases will pass through the economizer, then it will go to the air preheater. So air preheater will have the it may consist of the plates or tubes through which through which flue gas will pass. Okay. So degree of preheating will depend upon the type of fuel used, and another one is the type of fuel burning equipment, and third one is the rating operated. Okay, so degree of superheating, degree of preheating of the air will depend on the type of fuel used or type of equipment used where your fuel will burn, and the rating at which the boiler and the furnace are operated. Okay, so in case of the air preheater, as I have already told you, the hot flue gases will flow through the plates of the tubes, and the other side there will be the flow of the air, so that it will preheat the air to supply to the which will be supplied to the furnace. So preheated air will accelerate the combustion and it will facilitate the proper combustion of the coal. Okay, so there are the three types of. So first one is the tubular type, second one is your plate type, third one is your storage type. Okay, so three types of
मैम
preheaters are available. Yes, please.
मैम यहाँ रेटिंग कैसे कैलकुलेट होता है बॉयलर में, बॉयलर और फर्नेस का जो यहाँ पर लिखा है?
कहाँ पे?
ये ratings at which the boiler and
Ratings
furnace.
are designed, ratings are given as per the working pressure of the boiler.
Okay,
So
ma'am.
boiler
Ma'am,
rating IBR जो है ना Indian boiler regulation. I think I had discussed to you. Yes, please tell me.
yes, ma'am. Okay, ma'am.
तो IBR है ना इंडियन बॉयलर रेगुलेशन जो है उसके तहत ये जो बॉयलर का वर्किंग की प्रेशर के हिसाब से बॉयलर को रेटिंग दिया जाता है जैसे कि आपका फ्रीज का रेटिंग होता है 3 स्टार 4 स्टार उस टाइप का बॉयलर का भी रेटिंग देती है तो एग्जैक्टली जो वर्किंग प्रेशर के हिसाब से ये रेटिंग दिया जाती है ओके तो हाई प्रेशर बॉयलर का लो critical boiler or superheated boiler. So as per that, ratings are given. Okay. So if you wish, tomorrow I will show you some data also related to this boiler. Okay.
Yes, ma'am.
Okay. So three types of air preheaters are available. One is a tubular type, another one is a plate type, and storage type. Okay. So tubular type. So this is the example of a tubular type of air preheater. So in this case, the flue gases which will leave from the economizer that will flow through these tubes. These are the tubes are available. So through the tubes it will flow, then it will pass through the uh, okay. So it will pass through the tube, and another end there will be the flow out of the flue gases, so which will pass to the chimney. Okay. So in this case, the opposite direction your air will be travel. So this is the travel of the air. So here it is the air inlet, and another side heated air will be supplied to the furnace. So the air will take the heat from the flue gases, and that hot air will be supplied to the furnace. So there will be the soot hoppers are present near to the wall of the soot hoppers are actually placed near to the bottom of the air heater or casing. Okay, so this is the casing. So soot hopper means in this case the soot will be collected at the bottom and that can be removed from the other side. Okay, so this is the tubular type. So plate type preheater. Here the plate-like structure will be there, so over which high velocity air will be uh, supplied uh, over the plate, and hot gases will be supplied at the top or bottom side. So high velocity air will take the heat from the flue gases, which will be moved in opposite direction. So that is the plate type. And in case of the storage type, we will have the certain box inside which there will be the um, different wire mesh are available through which that flue gases will enter uh, and opposite side that flue gas will be uh, uh, move out from the chamber. Okay, so and other side there will be the supply of the air. So that way that storage type air preheater will act. So most of the time we are using this type of the tubular type only. So that's why I have shown you this diagram. So that flue gases which will leave from the air preheater, the temperature should be as low as the stack temperature, so that there will be the minimum loss, heat loss to the uh, stack or atmosphere. Okay, through the stack to the atmosphere. Okay, so this is all about your air preheater. So next one is the superheater. So the function of the superheater is to increase the temperature of your steam above the saturation point. So whatever the steam is generated, that is your wet steam. Okay, so that wet steam temperature will be increased by extending by taking the heat of the flue gases, so which will be exhaust to the atmosphere. Okay, so superheater is very much important accessory for the boiler. So this superheater can be used both in case of the fire tube boiler. So if you have remembered, there we have um, seen the internal structure of the Cochrane boiler and Babcock Wilcox boiler. So in both the cases, we are having the superheater. So as the superheater are used in case both in the case of both the fire tube and water tube boiler. So small boilers are not utilizing this superheater. So superheated, what is the advantage of the superheated steam? क्वेश्चन देखिए लिख लो. So advantage of the superheated steam is so steam consumption of the your turbine will it will decrease. So losses due to the condensation, that will decrease. Okay. So if it is a wet steam, so what will happen if it will flow through the pipe? There will be the condensation in the pipe as well as in the cylinder. Okay. So here efficiency of the plant will increase. So erosion in the blade will be eliminated. Okay, so these are the advantages of your superheated steam. So superheaters are located in the path of your uh, furnace gases, so that the heat available from the furnace, which is the waste heat, that will be utilized in case of the superheater. So this is the diagram for the superheater. This superheater name is your surgeon's superheater. रफ कॉपी में लिख लो, डायरेक्ट आंसर लिख रही हो क्या? So please wait for me 1 second, 1 minute. Okay, so there are the two types of superheaters. So one is the convective superheater. Another one is the radiant. So convective superheater will makes use of the heat in the flue gases, whereas the radiant superheater is placed in the furnace and the wall tubes receive the heat from the burning fluid through the radiant process. Okay, so radiant type of superheater are used where high amount of superheated high amount high amount of superheated steam is required. Okay. So this is the radiant superheater where it will take the heat from the radiation process. So convective superheaters here the heat of flue gases will be utilized directly by the convection method. So the it is the diagram for the surgeon's superheater. Okay, so if you are observing, it is the chimney, and this is the boiler cell. So steam will be collected at the top end. So wet steam will be collected. So here the wet steam will be supplied to the superheater. This is the pressures of the superheater. Here two headers are available. So that wet steam will take the heat from the flue gases, which will be uh, received from the chimney, and that heat is used to convert to the wet steam into the superheated steam. Then it will supply to the main steam pipe. So this is the surgeon superheater installed in case of the Lancaster boiler. So here the headers are present, and the structure of the superheater is U structure, which is made up of the steel pipe. So U tubes of steel pipe. So these tubes are arranged in groups of the four or two. Okay, so one pair of the headers is generally carries 10 of these groups, or um, so it may be the present in terms of the groups actually. So this is about your superheater, surgeon superheater. So the here the dampers are used, so which will control the flow of the flue gases. It will show the path of the flow of the flue gases. Okay, so this is all about your surgeon superheater. So today I'm stopping up to this. So tomorrow we will continue. So Deepika, please give me the attendance. So I'm unable to take the attendance. Okay.
Okay, ma'am.